afternoon. I'm so excited to be here. Since our launch of our industrial AI services, we've heard from hundreds of industrial and manufacturing customers just like yourselves. And I'm so excited to present our latest evolution on our industrial AI services to help improve your digital transformation journey. Today, we'll be hearing from guest speakers such as Shalika Pargal, who's the Senior Product Manager of our Industrial AI Services, as well as guest speakers from Baxter International, A.K. Karen, Senior Director of Baxter International, as well as Adam Aldridge. Since I started in this industry about 2.5 decades ago, that seems a little long, huh? We used to monitor only the most critical assets and the most critical applications. Today, you are able to apply industrial AI to hundreds or thousands of pieces of equipment that you could never even dream of monitoring in the past. We'll be able to show you, how customers today that previously couldn't monitor their assets and apply industrial AI services, whether it's computer vision, time series data using machine learning or anomaly detection across their plants, production lines, as well as their assets. We have a packed agenda today, and so what we'll do is give an overview of our industrial AI services, the evolution based on your feedback of our specific service, Monitron, which is an end-to-end vibration temperature sensing to machine learning application. And the bulk of the time we'll spend going through a real-life case study of how industrial AI can impact your operation, as well as how you can scale it across niche applications to across your overall production facility. So, just show of hands, who here has used the AWS app for a re:Invent? Yeah? Yeah? Anybody use the queue lines? Anybody use that to decide whether or not? No? You just drew a straw to see if the line was long, and you just figured out whether or not to get a badge? Well, those are the types of insights that we want to bring to you, right? So on apps that you're using today, be able to get real-time insights in terms of queue lines, in terms of how your pieces of equipment are performing, right? To people who can make the decisions, right? So if you're waiting in line and you look at, hey, look, if I go next door, that line is half the time that I could be standing there to get my badge. Why not do that? Right, so same thing with our industrial AI services. We want to bring those insights to the operators, the maintenance team, quality managers who are making the decisions for your operational facility. Right, in the past, it was really set to data scientists, IT experts to be able to manage your data as well as the data science models. No more. We'd like to take that step away, those machine learning steps, and the thought process is now more around what type of data do I need to drive my problems? So some areas that we're very much focused on are condition monitoring, being able to predict the health of your specific asset, as well as quality management, leveraging computer vision at the edge to be able to understand the quality of your production lines. So our focus in AWS, as I mentioned, is that we're trying to simplify the machine learning workflow. In the past, you need to have a data scientist, generally somebody of a PhD degree, to be able to select and process the data that you have, whether that's time series data, computer vision data. We know it comes in all sorts of forms. And that pre-processing from what we've heard from you can be between 40 to 60% of the time. And across our industrial AI services, what we do is we look for commonalities across this data, commonalities across these challenges of the data that you see, and to be able to automate away those. So things like timestamp alignment, imputation, traditional steps that you need just to get started in machine learning, as well as algorithms, right? You have hundreds or thousands of different algorithms that you can select from. We pre-select these different algorithms so that you don't need a PhD to determine what type of algorithms to select, and also the hyperparameters to tune them to specific applications. What we know is that every asset is different. Every line that you operate is different. You might say, okay, automotive and healthcare are very different applications, but what we found is even in the same manufacturing facility, you might have different lines that operate a little bit differently, whether that's how you operate it, however it's maintained, or the different products that you send through those different lines. Based on that, we're able to select the algorithms that are pre-built based on those operational data that you send in. So our focus is to completely automate those steps. So in the past, it might have taken you months to be able to fully develop and manage those machine learning models. Today, you can get started in a matter of hours. Literally going to Amazon.com, you can purchase our Monitron service, glue it onto anything in your system. We've heard everything from water pumps to HVAC pumps to anything in your operating facility, where you can automatically glue your sensor and be able to monitor your assets on day one. So specifically for this presentation, we're focused on condition monitoring and specifically around how condition monitoring can be applied to predictive maintenance. As I mentioned, across facilities we've visited, we've seen the most advanced facilities, right? So Amazon fulfillment centers where we have robotics, where we have AGVs, where we have the most advanced automation systems that we've seen, to facilities where they built in the 80s, not the 1980s, but the 1880s, where monitoring was just a dream. Right? And we've seen that whole gamut between the most advanced to these 1880 facilities, where some pieces of equipment are monitored, others partially monitored, and in other cases, there's fully developed machine learning models. And so because of that, we developed an array of different services and solutions based on those specific assets that you're monitoring. For assets that don't have any monitoring, like vibration, temperature sensing today, or continuously monitored today, we have a solution called Amazon Monitron, which we'll be discussing later, which is an end-to-end offering from hardware all the way to the software and application solution. If you already have condition monitoring, where you have vibration, pressure, temperature already monitored today, you can begin to build machine learning models using our service called Amazon Lookout for Equipment. As I mentioned, you bring in the data, and the system automatically decides what type of algorithms to be able to use for that specific machine learning model. And lastly, for the smaller subset of pieces of equipment where you've gone down the journey, you've built your machine learning model, we have Amazon SageMaker, where you're able to optimize that machine learning workflow, or your ML ops, to be able to optimize how you deploy those specific models. So what I'll leave you with before I hand it over to my colleague Shalika is that since the launch of our industrial AI services, we've worked with hundreds of customers, and our focus is not only the machine learning, but also how do we integrate machine learning into your operations. For Koch Ag and Energy Solutions, they've been monitoring their system through a remote monitoring diagnostic center for years now. They've been using a variety of different machine learning methods. However, they've been applying both Monitron and Lookout for Equipment to, one, start to monitor pieces of equipment that they haven't been able to continuously monitor, as well as being able to build machine learning models on pieces of equipment they haven't been able to monitor. And based on this new data and based on this new machine learning, they're able to detect issues hours, if not weeks, in advance of their previous method of detecting issues. In addition, one other customer that we're working with, they've embedded our Lookout for Vision service into their quality management system. That's where we see the most impact for our machine learning, is where we're able to fully embed machine learning into your operation. In this case, it was fully adopted into their quality management system, saving them tens of thousands of hours of manual labor. And instead, that data could be used to optimize their facility rather than monitoring that specific assembly line. And lastly, what I'll leave you with is that one of our largest customers and one of the largest asks is that, hey, look, we've seen that machine learning can be used by the few, and the few being data scientists and IT personnel. But how can I transform my organization where data is at the forefront? And the way that we see that is by automating the machine learning and bringing that closer to operators and maintenance staff. So that's the feedback from our customer GSEPS, is that they're able to transform their organization and be able to use machine learning across their organization. So without further ado, I'd like to introduce Shalika, again, the Senior Product Manager for Industrial AI Service.
Thanks, Alicia. I'm now going to go to the details of the buy or the out-of-the-box solution that Alicia mentioned. Before I get started, I just wanted to understand, any Monitron users in the crowd? Can I see a show of hands? You see a few? All right. So for others, Monitron is an end-to-end system that monitors industrial assets and detects abnormal conditions in these assets using machine learning. In doing so, it enables predictive maintenance in an easy and cost-effective way thus helping reduce unplanned downtime. You can get started in monitoring your rotating equipments like pumps, motors, gearboxes, and bearings using Amazon Monitron within a matter of minutes. Now let's look at how Monitron works. Monitron has a purpose-built wireless sensors that capture the temperature and vibration patterns of the asset. Temperature and vibration are good indicators of the health of the asset. These sensors can be enabled using near-field communication from the Monitron mobile app. These sensors have been optimized and built to optimize for both cost and simplicity. Next is the fully managed Monitron gateway. This gateway securely and automatically transfers the sensor data to the cloud. In the cloud, we have the Monitron service that analyzes the sensor data using ISO vibration standards and machine learning algorithms. And finally, we have the Monitron app. We have a mobile app and a web app, which are used to set up the hardware, which is the sensor and gateway, and to receive notifications in case of abnormal conditions on the industrial assets. Monitron is quick to install. Within a matter of minutes, a reliability engineer can set up the sensor and gateway and start monitoring their assets. The service uses machine learning to analyze the sensor data. So no prior machine learning knowledge or expertise is required to use Amazon Monitron. Since the launch of Monitron, our focus has been to try and add additional value for our customers around 3 core themes. The devices, notifications, and making Monitron data available to customers in a form they can add more value to. Starting with the devices theme, when we launched Monitron, our devices were certified for the US, Canada, EU, and UK. However, over time, we have seen that our customers who operate globally want to install or deploy Monitron in their overseas plants in Asia Pacific. This has now led us to certify Monitron in Australia, New Zealand, Japan, Turkey, and Singapore. To reduce the operational overhead for customers in replacing sensor battery and to reduce the overall cost of ownership, we have increased the Monitron sensor battery life from 3 to 5 years. This update was done via the firmware, so no action is required from the customer. The updated firmware has been deployed on all the sensors in the field using Monitron's over-the-air capability. So now if a customer has bought the sensors and installed it, then they can avail this benefit at no additional cost to them. Some of our customers had network protocol requirements which required them to use wired gateways. To address this need, we launched the Ethernet gateway, which facilitates the transfer of sensor data to the cloud using the customer's Ethernet network. Now the Ethernet gateway, along with the Wi-Fi gateway, which was available at the time of launch, provides customers with multiple options for their Monitron connectivity needs. Moving to our next theme, which has been focused around enhancing our notifications to provide additional value for our end user persona, the reliability manager and the shop floor technician. Our focus has been on adding more to the notifications, more commentary and details around severity, which is an indicator of the health of the asset, type of notification, which is determined if the abnormal condition is seen either in the vibration data or in the temperature data, the source of the alert, which can be based on the ISO 20816 vibration standards, or it could be due to ML-enabled models. ISO-based notifications are a result of or determined by the ISO thresholds. We have ISO thresholds which are associated with 4 different equipment classes. These equipment classes are very broad, so sometimes we have customers who run their equipments in different operating envelopes. This results in getting notifications which might not apply to the particular asset. To address this, we now allow customers to mute their ISO-based notifications if they want to do so. Monitron now provides indications when a sensor or a gateway goes offline. This tells customers that their devices have gone offline and not sending information to the cloud. The customers can troubleshoot and bring the devices back online and resume monitoring their assets. Our last theme has been focused on making Monitron data available and accessible to customers within their own ecosystem. Amazon Monitron can now stream live sensor data to a Kinesis data stream. So customers can use this data, analyze the data, and create work orders in their asset management systems like IBM Maximo, SAP PM, or Infor, and others, so a technician can be sent to look at assets with issues. We have seen many of our customers build operational dashboards to monitor the health of their assets. Given the data in the Kinesis data stream, these customers can now augment these dashboards with the real-time data and insights from Monitron. The Monitron data and inferences can also be used and leveraged along with telemetry data and operational data to build advanced analytics for other use cases. Now changing gears, we want to show you Monitron in action at Baxter's manufacturing facility.
Of healthcare and life-saving products. Our mission is to save and sustain lives. We have 70 plus manufacturing sites located globally, and we run 24/7, 365. Every minute of production is very critical to us, and every instance of downtime that we can avoid is crucial and very valuable.
Most of our systems were manual inspections, which requires a lot of resources and labor. In some cases, we have to enter confined spaces, so there's a safety aspect. You have to shut down critical operations to do the maintenance activities.
Equipment reliability is very, very critical to us. We have over thousands of manufacturing assets that we need to monitor. Monitoring these assets using time-based methods or periodic alerting wasn't good enough. On the other hand, Amazon Monitron gives us machine learning and AI capabilities that helps us to generate custom vibration and temperature profiles for every asset, and this was truly a game changer.
Without further ado, I'd like to welcome A.K. Karan and Adam Aldridge to walk us through Baxter's journey with Monitron.
Hello and good afternoon. Hello. Yeah, what a great video, right? Just because it is not I'm in that video, but truly it's a great video. So let's start with who we are, right? Baxter. So Baxter is a global manufacturer of healthcare and life-saving products. We have a pretty broad portfolio, around 50,000 SKUs. But the big thing is, we impact the life of 350 million patients in a year, in a given year. That is the reach of our products. And from a manufacturing footprint, we have over 70 manufacturing sites located globally, and we have our own challenges in terms of how to keep our operations running 24/7, 365. So talk about why we embarked on this journey, right? So if you look at one of the words that was used, I would say, in the last few years, you heard resiliency. So when we look into operations, you knew the supply chain. It's a close interlink of all those different groups, functions. But we said, from an operations standpoint, we want to be resilient. We don't want to be the weakest link. And especially we are facing labor shortages. How can we find? We have jobs, but we can't find people. We have inflation. We have cost pressures. So how do we keep our operations running 24/7, 365? How do we build resiliency? And that was going to be the determining factor for us to start on with, I would say, a predictive maintenance tool. So what were we doing before, right? It was not like we didn't have any systems. We did have systems. We used condition-based monitoring. We did have our technicians who would go on our rounds. Every day they just go check all the assets. We had thousands of assets. So going on a periodic frequency, checking the assets, but things might break down during those checks. So when all those our systems fail, they can create a very serious disruption to our supply chain. So how do we kind of have a system that's going to monitor these assets 24/7, 365, continuous monitoring? Just think like a Fitbit on you, right? On a person. It tells you all your vitals, making sure the equipment is operational, it's in a good, healthy state of operation. And that's one of the reasons we started this journey. But then, when this kind of goes down, we're always waiting for this element of surprise. If this goes down, so what do? Call technicians, dispatch people, bring an emergency maintenance crew. It creates havoc. So how do we kind of go from the existing tools to more of a preventive based approach? But before I go on, I would say, what are we looking for in terms of the value proposition? First and foremost, right, we said speed is going to be key. When we talk about speed, it's not about, we look for, as a company, we look at weeks to kind of get this thing, days and weeks, not months and years. And it has to be cost effective, because how can we generate quick value, right? And also the big thing is, I mean, we have 70 sites. How do we scale this? So it's just, it's not like you have to go reinvent when we go from plant 1 to a plant 2 across global sites. So Monitron gave us all those features that we were looking for. And like some Shalika and Alicia mentioned, solution is end-to-end. Like you just slap the sensor on an asset, flip the button on, say stream the data. And that's, as a consumer, that's what we did. So the system had data streaming services to the cloud, analytics built in, especially all this embedded machine learning, that kind of gave us a custom vibration profile, a custom temperature profile for every single asset. Asset could be 10 years old, could be 20 years old, could be 5 years old, right? But every single asset had a unique signature that we kind of used, and machine learning helped us to take it to the next step. So this was truly, I would say, a game changer, because it helped us to generate value very, very rapidly. So I'm going to pass it on to Adam. He's going to talk about operational challenges.
Yep. Hello, everyone. So Adam Aldridge, Reliability Engineering Manager at our flagship facility, helped lead and develop this program and deploy it throughout our facility. And I'm going to be talking to you about our first case scenarios and everything that we ran into and the learning curve that we did over the 1-year journey that we've had since we started installing Monitron sensors. So some of the operational challenges that we were trying to be able to successfully mitigate with the way we were doing it compared to the way we're able to do it now with Monitron is real-time data collection. As you can see in the top picture in the photo, we've been doing manual data collection for vibration analysis, where a technician will go out and physically sample each site, each motor every month. We'll get one reading for a whole month's window. We'll send it to a third party for a data analysis, and then we'll receive that information back. So that comes at a cost to the site for the third-party analysis, as well as a lot of labor for our technicians to collect this data. Now we're reading one reading per hour and being able to have the machine learning to notify our technicians when there's a potential failure being presented, and then we can go out and investigate. It also has allowed us to do rapid decision making and readily available data to make decisions. So we have the trend lines from the Monitron app, as you can see in Figure 1 and Figure 2. We're able to monitor those and determine, is this issue developing something that we need to go in and investigate, or do we want to continue watching it to see how it develops over time? We've had issues where it's took almost 3 to 4 months for it to double in value for its RMS velocity. So it's not something that would immediately recognize, we need to go out and respond immediately, but after you look at that data over a 3 to 4 month period, there's absolutely a trend developing that we need to investigate that potential cause of failure. It's increased productivity. So we have a fully deployed maintenance and predictive maintenance program at our facility, but you can imagine how much time it takes in a 1.4 million square foot facility to do those manual data collections. Now we're able to use the app, monitor the app, and we're able to use our technicians' time pursuing other predictive maintenance technologies or further scaling our Monitron program. And it's a disruptive and complementary technology. The disruptive part should be pretty clear, where we talked about we've been able to get away from our manual route running and we're bringing it in-house, but it's also been complementary. As you can see in Figure 1 and Figure 2, when our technicians respond to it, we don't just go out and listen to the vibration data and immediately say, let's do a repair. We want to further investigate and get to the root cause of what that problem is before we go through a costly repair process. And Figure 1 is one where we received a machine learning temperature alarm. We go out with our thermal imaging cameras, we take pictures of the motor gearbox on the one that we're in question and then the one next to it, to where we can see a like-for-like comparison, and we're able to determine that it's 30 to 40 degrees Fahrenheit more hot than the neighboring one under the same load and same conditions. So that's a determination. Let's start initiating a repair. We've also had a lot of benefit with utilizing and pairing this with ultrasonic technologies, as you can see in Figure 2 and 3. Figure 2 comes right out of the Monitron app, for where we would respond as our technicians, and then we take our ultrasonic listening and actually listen to that bearing on the motor that we were alerted to with Monitron, confirm and set a second opinion that yes, absolutely, there is an additional wear in that bearing, and then we initiate our repair work after that, as opposed to just listening and putting in a repair work without doing some kind of second confirmation, and then also a robust visual-based inspection. So our first win came during our proof of concept, and it's actually our single biggest win as well, ironically enough. But it was our cooling tower that provides chilled water to 2 production areas, 33 machines in that area, and they're very sensitive to the room ambient temperature to be able to produce their product correctly. So we received a high vibration ISO alarm, and our technician responded and was able to identify the gearbox leaking oil and in an early stage of failure. But because we were so early in that failure curve, if you're familiar with a P to F curve and the probability of failure, we were able to catch it much sooner. And as you can see in the pictures, this is a very large cooling tower, so you can imagine the size of the gearbox as well, larger than the podium here. So we had to have a contractor crew and a crane come in to do that repair work. So the real value is we chose when that cooling tower went down. We did our repair work at minimal cost instead of having an emergency deployment for our contractor. And we had no downtime to that production area that we served because we was able to rearrange our chilled water distribution and pick it on a day where it was very cool so we wouldn't have as much temperature problems. Our estimated value creation for that one single instance was roughly 400 machine hours of downtime avoidance when you added it all together. So it has a major impact and a very big first win. So some other things that we've been able to learn and establish as we've been going through this journey. Normal operating baselines in a matter of weeks instead of years. So we're able to determine how our equipment is performing and what is and isn't normal. In figure 1, you can see where we had normal operation for a large window of time, and some equipment vibrates simply at a larger RMS velocity than other equipment, but it still can be considered normal, especially in a facility that is older like ours. Some equipment just is already at an early stage of failure, but we're not going to respond to it at that time. We're not getting a pure baseline from a beginning installation. We're able to improve our asset maintenance plans. So one of the issues that we found in some of our rotating spares where we'll have redundant systems, which basically will mean every roughly 6 months we'll switch from one pump and motor to another one, and then we learned that our maintenance practices were not sufficient for the motor that was not being ran at that time, because we continually found when we switched, within a couple of weeks, a lot of times we were getting early stage coupling failure or finding out other issues from where that motor had been sitting dormant for about 6 months. So we did a root cause analysis and we was able to identify some of our maintenance practices that we were not doing when that motor was not operational. We've changed those to try to eliminate that, because granted it is a redundant system, but if you lose one of the motors and pumps, now it's not a redundant system and it is for absolutely critical equipment in our facility. So we've also been able to identify the differences between the ISO and machine learning alarms. We have responded to and got tangible wins from all varieties of alarms provided by the Monitron system. So we get the ISO alarms and we're seeing high volume, high RMS velocity. We're not capturing the trend over time patterns like we get in our machine learning program, but we're able to see, well, this should not be as high as it is, and we're able to go out and investigate. And of course, the way this functions, after 6 hours, you're able to start bringing in those ISO alarms, and you have to wait a 21-day period for your machine learning to take an effect. So you're able to start getting alarms within 6 hours of installation, and then within a couple of days, you have enough trend data to see how that's been progressing and start responding to it. It's also been something that we've been able to transform. In our plant, we already had a predictive maintenance program and culture established, but as we've been working on other facilities that do not have that program established, Monitron is able to do as a foundational for all of the predictive maintenance in the areas. We're able to eliminate our manual route running not only from vibration analysis, but ultrasonic analysis and thermal imaging routes, utilizing the capabilities of the Monitron program to monitor a large amount of assets with minimal amount of technicians, and then use those technician time to do supplemental technologies when we get those Monitron alarms, as I showed in the previous slide. So in figure 2 is probably one of our best examples of how we've been learning our Monitron alarm and the machine learning program. It was one of those redundant systems I made an example of a second ago. And you can see where it turned on, and that's where we switched from one pump to the other. We actually got our first machine learning alarm in an area that we would have very much considered normal operation based off of not having a very trend over time change in pattern. However, as we continued to watch it, then we started seeing an exponential climb towards the end of that graph. And as you can see, it continued getting worse and worse until we pulled the trigger, did the work order, was still able to get it, catch it before any kind of failure. And that harkens back to like AK was talking about with the supply chain woes and everything like that. We aren't able to get motors and pumps and gearboxes in a week like we used to. Sometimes it's a month lead time, 2 month, 3 month lead times. So the more early in advance we're able to determine there is a failure pending on this equipment, we're able to order our supplies and not have to depend off of our stockroom supplies or have extended amount of downtime because we cannot get the part in time. And that's the real value of the predictive maintenance in the Monitron. So our journey continues. So we're only one site out of the 72 facilities that Baxter has. We started with the 400 sensor proof of concept, and that was in November, December of last year. We have since scaled the site to 2,600 sensors, with the last few going in during our planned maintenance outage in this upcoming Christmas in areas that we're waiting to shut down equipment for confined space entry. But that's just 1 year, 2,600 sensors, and a team of 5. 4 predictive maintenance technicians and myself have been helping to lead this. And now we're scaling to other facilities. We've actually got one facility that had a shutdown earlier than ours, and they're actually at 100% already, so they've surpassed us with their deployment even though we're the original site. But that just shows you the speed and scalability of the deployment solutions that we're able to do. A team of 2 to 3 individuals can install several hundred sensors with machine downtime in a matter of a couple of days, and you start getting data within 6 hours after that. So over the next of our real 5-year plan is we're targeting to finish our global deployment at the other 70 production facilities. And I think we'll turn it over to a question and answer section.